Every time you climb into a Ford F-150, a Chevy Silverado, or even a family SUV cruising down an American interstate, something invisible is helping to keep your windshield from tearing away from the frame at highway speeds. It's been there your entire life, on every car you've ever ridden in. You've looked straight at it thousands of times and assumed it was just decorative. It isn't. The answer is the frit. Far from a mere design choice, this ceramic band is baked permanently into the glass before the car ever leaves the factory. And as it turns out, its existence is 100 times more critical to your safety than you think. But to truly understand the story of the frit, we have to start with the windshield itself. What is a windshield actually made of? Imagine standing inside a manufacturing plant, watching a windshield being born. It's actually a structural sandwich, 2 layers of glass fusing a thin plastic film called PVB in the middle under intense heat. This ensures that if it shatters, the shards stay locked in place. Safety is its ultimate mission. It acts as a transparent, load-bearing wall that keeps the roof from collapsing and backs up the airbags. A piece of glass this complex and vital couldn't rely on just any ordinary attachment, and how it's locked to the car is the exact reason the frit exists. Why rubber gaskets had to go? From the 1940s through the 1970s, windshields were held in place by rubber gaskets. While simple to assemble, they quickly degraded, vibrating at highway speeds, shrinking in cold weather to cause water leaks, and creating aerodynamic drag that wasted fuel. As car design evolved, the windshield became a vital structural component rather than just a sheet of glass. A rattling, leaking rubber ring wasn't going to cut it anymore. Automakers needed a permanent, industrial-strength bond to lock the glass directly to the frame. The answer was an advanced adhesive, and that adhesive is the entire reason the frit had to be invented. The one thing that destroys the glue. The adhesive that replaced the rubber gasket is polyurethane, a thick, industrial-grade glue that cures into a bond engineered to be stronger than the glass it holds. Once it's set, if you tried to pull the windshield off the car by force, the glass would give before the glue did. But polyurethane has one vulnerability: sunlight. Think about a rubber band left on a sunny windowsill. After a few months, when you stretch it, it snaps because the UV radiation has been quietly breaking down the material from the inside, weakening it in ways you can't see until the moment it fails. The adhesive holding your windshield in place works by a similar principle. Whether the car is baking under the Arizona sun, crossing Nevada desert highways, or sitting outside through freezing Michigan winters, UV radiation slowly breaks the adhesive down over time. What the adhesive needed was a permanent barrier between itself and the sun. Something that would last the life of the car, applied before the car was assembled, before the glass was even cut to final shape. That's the frit, and here's where the story gets genuinely surprising. What the frit actually is. Here's the part most people get wrong. The frit is not a coating on the glass. It cannot be scratched off because there is no surface to scratch it from. The frit starts as a ceramic enamel, powdered glass fused with metallic oxide pigments, applied to the raw glass sheet through a silkscreen process before the windshield goes anywhere near its final form. Then the entire assembly goes into a furnace, reaching temperatures above 1,100 degrees Fahrenheit. At that heat, the ceramic doesn't just bond to the glass, it melts into it. When the windshield comes out of the oven, there is no longer a layer of frit sitting on top of a layer of glass. There is just glass, with a black region and a clear region and no seam between them. Think about the glaze on a ceramic mug. You can't peel it off. The glaze and the mug are one material now, fused together in the kiln at high heat. That's what frit is to glass. The frit will outlast every other component on the car, including the car itself. It was designed that way because what it's protecting has to last just as long. So far, you've seen what the frit is and the problem it was built to solve. But protecting the adhesive is only part of the story. Why that band has to be exactly that shape, that color, and those fading dots. The answer is coming up next, and it goes far beyond anything you'd expect. 3 problems, 1 strip of ceramic. Once you understand what the frit is, understanding what it does makes immediate sense, because every function follows directly from what it's made of. The first is UV protection. Black ceramic absorbs and blocks ultraviolet radiation with total efficiency. The adhesive beneath the frit band will not see direct sunlight for as long as the car exists. The second job is giving the glue something to grip. Glass is almost perfectly smooth at a level where adhesives struggle to hold long term. But when the frit fires into the glass, it creates a texture across the ceramic at a level too small to see. Tiny peaks and valleys that the adhesive flows into and locks around, the way glue holds better on rough wood than on sealed lacquer. The frit doesn't just protect the adhesive, it actively helps it hold. The third is visual concealment. Polyurethane adhesive is not attractive. It goes on in a thick, uneven bead and spreads unpredictably under pressure. The frit band is wide enough to cover every inch of that application from every viewing angle, inside and outside the car. So what you see from the curb is clean, matte black. And what you never see is the structural reality underneath it. 3 entirely different engineering problems. One strip of ceramic baked into the glass before the car is assembled. But that still leaves one question the frit band itself raises every time you look at it. Why does it fade into dots instead of stopping clean? Why the dots and why black? The answer to those questions has absolutely nothing to do with aesthetics. It all comes down to how glass behaves when it's heated unevenly. Modern windshields are curved to match a car's aerodynamics. To get that shape, the glass goes into a furnace until it's soft enough to bend. Because black absorbs heat faster than clear glass, the solid ceramic frit at the edge gets significantly hotter than the center, creating a sharp thermal cliff. Physically, hotter glass wants to expand while cooler glass resists. This tug-of-war creates intense internal pressure, known as stress. If that temperature drop is too abrupt, the glass will fracture during manufacturing or warp, causing optical distortion that ruins visibility. To fix this, engineers use geometry via a halftone pattern. As the dots shrink toward the center, the ratio of black to clear surface gradually decreases. A zone with 80% dots runs hotter than a 50% zone, which runs hotter than a 20% zone. This creates a stepped temperature gradient rather than a sudden drop. Heat flows smoothly, the glass expands uniformly, and the windshield emerges perfectly curved, clear, and structurally sound. As for the color, black is a strict requirement, not a design choice. The ceramic layer must block UV radiation at the thinnest effective application. Lighter pigments would need to be applied much thicker to achieve the same opacity, which would trigger its own thermal and optical issues. Black is the only choice that gets the job done. Everywhere you've already seen it. But there's one more place it appears on your windshield, and this one has nothing to do with any of that. If you look right behind your rearview mirror, you'll find an isolated cluster called the third visor frit. Your car's standard sun visors leave a triangular gap right above the mirror, letting in blinding glare during long evening commutes on crowded California freeways. This clever geometric pattern diffuses that harsh light while keeping your sightline clear. And once you know what frit is, you start noticing it in places that have nothing to do with cars. Look at modern glass skyscrapers. Those geometric patterns on the facade are ceramic frit, regulating interior temperatures and blocking glare. You'll also find it in your kitchen. That black band around your oven door is the exact same technology, protecting heat-resistant adhesives from extreme thermal cycles every time you cook. From skyscrapers to household appliances, this invisible lifesaver has been hiding in plain sight your entire life. Every road trip, every daily commute, every late-night drive across America has relied in part on something most people never even notice. If there's something you walk past every day and wonder about, drop it in the comments. We read every single one, and the best suggestions make it into future videos. Don't forget to subscribe so you don't miss what's coming next.